Alright, today we're going to take a look at the Arrhenius acids and bases and how to identify them and what they do, why are they called acids and bases in the first place. If you looked at the first set of notes, you'll remember that from a definition, an Arrhenius acid is any compound that's going to produce hydrogen ions as the only positive ion in solution, meaning when it's dissolved in water. The Arrhenius bases are any compound that's going to produce hydroxide or the OH minus ions as the only negative ion. So how do we recognize these? First off, if we take a look at all these compounds here, we've got hydrogen in front of three of them. But what about that last compound, that CH3COOH? That is still going to be an acid. It's an organic acid, and it ends with this COOH ending here. So this is going to be the key for us in recognizing it. The acids are either going to start with hydrogen in front, 1, 2, or 3 hydrogens, or they're going to end with this COOH. Someone told me first, hey, you know that acids are cool, so that's how we recognize them here. So what happens when we dissolve these acids in water? The compound, even though it's molecular, the water will pull apart and ionize these acids. So the HCl, the hydrochloric, is going to produce a hydrogen ion, and it's going to produce a chloride ion. The hydrogen and the chloride are pulled apart. What about the HNO3, the nitric acid? It is going to make a hydrogen ion also. It's also going to make the nitrate ion. So we have an H plus and an NO3 minus. The sulfuric acid is a little bit more complex. It has 2 hydrogens, and it's going to take 2 steps to get this done. But the net result is that we're still going to pull off 2 hydrogens. So the first one, we could pull off a hydrogen, but that would make HSO4 minus. And then that HSO4 is going to further lose another hydrogen to make the SO4 2 minus. The reality, this is a 2-step ionization of sulfuric acid. We often will write this as an overall reaction. Notice we made 1 hydrogen and then we made a second hydrogen ion over here. So sometimes we'll just shrink this up we would make this, say, 2 hydrogens, and then that would leave us with the sulfate ion as the negative ion. So notice, we've got a hydrogen and a chloride, a hydrogen and a nitrate, 2 hydrogens, and a sulfate ion. We also have other classifications. We would say that these are monoprotic acids. What does that mean? Monoprotic means it made 1 proton, it made 1 hydrogen. The sulfuric acid would be considered diprotic acid. It has made 2 hydrogen ions. We do have to be careful with this acetic acid down here, this organic acid. We will see this one of 2 ways. If you see it in this organic method, the COOH, the only hydrogen that's going to ionize is that last one. So as a net result, we would have CH3COO minus plus the hydrogen. As a first-year chemistry student, we will often see this in the other form, which would be written as HC2H3O2, acetic acid. And in this case, again, it's only that first ion, and then this entire polyatomic ion, the acetate, would be the other one. These 2 are the same thing, 2 forms of the same compound. It just depends if we're looking at it from an acid-base standpoint or if we're in the organic unit. So this is a look at acids. What do they have in common? We've got hydrogens. Either we've got hydrogens here, or we've got the hydrogen at the end of that COOH as an organic acid. All right, so what about the bases? Bases have hydroxide ions as the only negative ion. Now, I'm just going to be careful here. One of these is not a base. I'm throwing this up here as the watch out, the non-example. Hydroxide ions are OH with a negative. So when these sodium hydroxide and the magnesium hydroxide dissociate in water, we get a metal and we get a negative hydroxide ion. That makes it a base. It's ending with an OH, but we got to be careful that it also starts with a metal. Magnesium is a metal. The OH is at the end. The difference here is that we have a magnesium ion, but how many hydroxides are there? There's 2 of them right here. So we've got 2 hydroxide ions. We can put that 2 as a coefficient. What about this last one here, the C2H5OH? This OH is here. It looks like a hydroxide. It's often going to be that wrong answer that someone that's making a test is trying to see if you're paying attention. This is not a metal. This is nonmetals. This is going to be an organic compound. This is technically an alcohol and not a base. So we want to say, hey, watch out for this one. All right, this one is not a base. It is not going to dissociate at all when it's dissolved in water. It's going to stay intact. So there you have it. We had the acids, we had the bases. The bases are going to make 1 or 2 hydroxide ions as negatives. The acids are going to make a hydrogen. And if we're getting real picky here and being real looking ahead, being forward thinkers, the acids make hydrogen ions. The bases make the hydroxide ions. What happens when a hydrogen and a hydroxide come together? We get what's called neutralization. We get, freaking box this off, an H plus and an OH minus. If we put them together, what do we get? We get water, right? Which is how we neutralize acids and bases and make neutral water. I hope that helps. If you have any questions, again, let me know. All right, thanks.